Hi there, folks. Today we're looking at trigonometry, and we're going to look at it from the most basic perspective, just looking at our basic trig functions and how we use those things to find pieces of right triangles, okay? And so trigonometry is at its core based on right triangles. We do have some things that allow us to use trigonometric functions to expand outside of just right triangles, but right triangles have special ratios that relates the angles and the side lengths. And here's the trig functions that we talk about. There's sine, cosine, and tangent, all right? And really, each of these represents kind of an operation based on the relationship of the opposite sides. And so when you think about this, think about sine, cosine, and tangent. Almost think of it as an operation that we're doing. And that operation will always happen to an angle. And so it's basically the sine of some angle equals the side that's opposite that angle over the hypotenuse of the triangle, okay? When you talk about cosine, it's the cosine of some angle. So I'm taking the cosine of an angle, and when I do, that will equal the length of the adjacent side, the side that's adjacent to that angle, and over the hypotenuse, okay? And then the tangent, once again, I'm taking the tangent of some angle, all right? So literally on my calculator, we'll be plugging in tangent of 30 degrees or tangent of 45 degrees or tangent of 60 degrees, okay? We'll be plugging in the tangent of an angle, and when I plug in that tangent of that angle, it should equal the ratio of the opposite side over the adjacent side. All right. And, one of the big things here is you have to remember which of these things is which. You have to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And the classic way that students remember this is they remember Sohcahtoa. And you just have to remember how this is spelled. All right. But Sohcahtoa is kind of that idea of the ratios that we have here. It's sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent, okay? And so really we just have to remember which of these expresses which ratio, and then from there most of the work is just done on the calculator, okay? But please understand that when we do the sine, it's the sine of some angle. We have to plug an angle into the sine function, and then it will equal this ratio, all right? It's cosine of some angle, and then it will equal that ratio. It's tangent of an angle, and then it will equal that ratio, okay? We use these like operations, okay? When we take the sine of this angle, it gives me this ratio, okay? For example, if I look at something like this guy, it just says to list the ratios for angles A and B, all right? And so when we talk about A and B here, I want to list all the ratios. We don't do the right angle. We only talk about this from the perspective of the non-right angles in the right triangle. And so for this one, again, I don't know what angle A is, but basically it would be this. It would be, if I start with sine, it would be sine of A. Really, we're talking about like the measurement of angle A, okay? And so we don't write it like this. I'm just going to write sine of A. I'm going to change this in a second. But really, it's sine of whatever the measurement of angle A is. So if angle A was 20 degrees, well, then inside of here would be the sine of 20 degrees equals this ratio, okay? And so that's the idea here. We're plugging an angle measurement into the sine function. Since we don't know what that is right now, we generically just say the sine of A. But really, it's the sine of the measurement of angle A, okay, if we want to think of it that way. So the sine of A equals. So for the sine, it's opposite over hypotenuse. So think about angle A. Angle A is this one right here. So which side is on the opposite side of the triangle, okay? Which side is opposite that angle? And the answer is, well, CB is opposite angle A. Well, that's a 10, okay? So the sine of A equals opposite, which is 10, over the hypotenuse. So then I ask myself, okay, which of these is the hypotenuse of the triangle? And the answer is 26. Okay, so that's the ratio that I'm looking for. And of course, I could reduce this ratio. I could call it a 5 over 13. Okay, not that it makes a really big difference here, not that it matters that much, okay, because typically when we're using this, we're going to be solving, and we're going to be plugging things into our calculator. Reducing the fraction is not going to matter much when it's all said and done, okay? But again, if I knew the sine, if I knew the angle measurement at A, it would be sine of that angle measurement equals this ratio, okay? Let's talk about the cosine of A. So once again, it would be the cosine of that angle measurement. I'll just call it A for now because I don't know what it is. So once again, I'm looking at this angle. Well, this is adjacent over hypotenuse. Now, the problem students run into is they look at this and say, well, aren't there two sides that are adjacent to angle A? Two sides that are next to this? Yeah, this is adjacent to angle A, the 24, but 26 is also adjacent to angle A. All right, and the idea behind the opposite and adjacent, when we're referring to the opposite and adjacent, we're referring to the legs of the right triangle, not the hypotenuse. And so if I ask the question, which leg is adjacent to A? See, the legs are the 24 and the 10. The adjacent leg is the 24. And now the hypotenuse, once again, is the 26, okay? And again, I can reduce this fraction. I'll call it a 12 over 13, okay? But again, if I knew the measurement of angle A, it would be the measurement, it would be the cosine of whatever that angle happens to be, whatever that measurement is, equals the 12 over the 13, okay? And then same thing with tangent. If I talk about tangent, again, it's tangent of the angle, whatever that angle happens to be. I don't know what it is right now, so I'm calling it A, all right? But if I knew the measurement of A, I would just plug that number in there, okay? And this is going to be opposite over adjacent, so opposite was 10, and adjacent was 24. And again, when I talk about adjacent, I'm talking about the leg of the triangle. It's the adjacent leg. The hypotenuse is its own thing, okay? And again, I can reduce this. That's going to be a 5 over 12. Okay? And now let's do the same thing, but from the perspective of a different angle. See, when you think about opposite and adjacent, it depends on the perspective of the angle. With A, the adjacent leg was 24, but the opposite leg was 10. If I do the same thing with angle B, let's do the sine of angle B. Again, I don't know the measurement of it. If I did, I would plug that measurement in here. If it was 40 degrees, I'd plug a 40 degrees in for B. Okay? And so that equals now opposite over hypotenuse, but now I'm looking at the perspective of this guy. So if I'm at angle B, now the opposite leg is going to be the 24. Okay, so this is going to be 24 over the hypotenuse. Well, the hypotenuse doesn't change, that's 26. And again, I can reduce that. That's a 12 over 13. Okay, if I do the cosine of B, once again, the only thing that's changed is the perspective. When I'm at angle B, the adjacent leg is now the 10, and the hypotenuse is 26. And once again, I'm going to reduce that, so that's 5 over 13. Okay, so just getting an idea of how we have to construct these things, how we construct the ratio based on which angle I'm looking at. All right, and then tangent of B. Again, from the perspective of angle B, the opposite side would be the 24, and the adjacent leg would be the 10. And of course, I can reduce that. It's going to be a 12 over 5. And you can see right away the only thing that changes in terms of the perspective, the sine and cosine kind of switch their ratios when I look at the different angles. So the sine of A was 5 over 13. Well, that's the cosine of B, okay? And again, it's only because the perspective is changing, all right? When I'm at a different angle, well, it's a different side that's the opposite now, and it's a different side that's the adjacent now, okay? So here's how we use these things. This is where we're going to plug it into the calculator. Notice I have an angle measurement this time, okay? But the thing I'm missing is some of the sides of the triangle. So it says use trig ratios to set up a proportion and solve for the missing side. And so what I want to do here is I'm missing two of these sides. I'm going to call this one X, and I'm going to call this one Y, okay? And so the idea here is I want to find X and Y based on the fact that I know angle B is 55 degrees. Now, granted, I could find angle A as well, but since angle B is already written here, let's go from the perspective of angle B. And from the perspective of angle B, this would be the X would be the opposite side, and this guy would be the adjacent side. And so there's, as we kind of look at our different trig ratios here, we could say something like, sine of B, well, I actually know the measurement. That's 55 degrees. See, that's what gets plugged into the sine value here, okay? And then this, I'll be able to literally plug it into my calculator. It will give me this value. But the sine of 55 degrees should equal, well, that should equal opposite over hypotenuse. Well, the opposite side is the X, and the hypotenuse is 18, all right? I'm going to set up all three trig ratios here. I'm going to do cosine, just so you can see which one we're actually going to use. Cosine of 55 degrees. Okay, so doing the cosine of B, so the cosine of 55 degrees, that's going to equal the adjacent leg over the hypotenuse. That's y over 18. And then the tangent of that guy, tangent of 55 degrees, well, that's going to equal opposite. The opposite side is x, and the adjacent side is y. Okay? And so when I take the tangent of that angle measurement, when I take the tangent of 55 degrees, it should equal the ratio that I get when I do the opposite of the adjacent side. And so as I look at these, you can hopefully see that one of these can't be solved. Okay? And again, the sine of 55 degrees, the cosine of 55 degrees, the tangent of 55 degrees is just a value that my calculator is going to give me. Okay? So I'm going to get that value, and I'm just going to solve this ratio. Okay? But see, the problem here is the tangent of 55 degrees has too many variables. When I look at this, I can't solve this for x or y. There's too many variables here. And so the idea is you have to choose which trig ratio will actually allow you to get to the answer. See, when we look at this guy, because I have the 55 degrees, the thing that's given is the hypotenuse. I know the hypotenuse, which means if I want to find missing values, I need to use trig ratios that use the hypotenuse. Okay? And if I wanted to find the opposite side, I want to use the sine function. All right? If I want to find the adjacent side, then I want to use the cosine function. So that idea of looking at which angle I have, which side is given, will help me establish which trig function, which trig ratio I want to use. Okay? And so here's how this works in terms of solving this thing. Like this first one, I could just multiply each side by 18. Okay? Or you could think of it like a ratio. A proportion. A lot of students like to do this. They put it over 1 and they cross multiply. X times 1 is an x. And when I cross multiply here, 18 times the sine of 55. Okay? And now this is a job for my calculator, okay? And on your calculator, you should already have these functions established, so that should have a sine, a cosine, and a tangent button. We do have to be a little bit careful. Let me pull up my calculators here. All right, so I have 3 calculators pulled up here. I've got the calculator that's provided in Schoology when you take these assessments. I've got a TI graphing calculator, and I've got a Casio graphing calculator. And yes, one of these, of course, is more impressive than the rest, but let's not talk about that right now. The thing you have to do before we start here, because I'm talking about angle measurements, see, in geometry, we only have angle measurements in terms of degrees. That's how we've studied that. But when you get a little bit further, when you get into things like pre-calc, you'll use another measurement for angles called radians. All right? And most calculators are set up to be in radians automatically. All right? If you look at the Schoology calculator, right here you see this RAD, and really that's a toggle switch. If you hit that, see it changes from radians to degrees. And now you see the DEG, that means now we're talking about degrees. Now I'll be able to use that calculator in terms of degrees. Same thing with the TI. You're going to have to hit the mode button. And right down here, the third one down, right now radians is selected. I have to go and select degrees, okay? And then you can exit out of there by hitting second quit. And then on the Casio graphing calculator, you're going to go to setup. It's right above the menu option. See, setup is in yellow, so second setup. And right down here, you see angle. It's marked as angle. It says radians right now. I'm going to select degrees, which is F1. Okay, now it says degrees, and now I hit exit. Okay, I have to make sure that my calculator is set up to use degrees instead of radians. And for this particular example, I wanted to do 18 times the sine of 55 degrees. So unlike the Schoology calculator, you just hit 18 and then times the sine of 55 degrees. Okay, and hit enter, and there it is. There's your answer. Okay, with the TI graphing calculator, same thing. It's just 18 times, and you don't even have to hit the time sign. You can just type it right next to this, 55 degrees, enter. And here, 18 times the sine, 55 degrees, enter. Okay? And so I get a 14.74. All right? So for this one, when I plugged it into the calculator, I got x equals a 14.74. And that's it. That gives me the length of AC. Now I have the length of AC from a geometry perspective. I could even say AC equals 14.74. But now I have to find the other missing side. I have to find y. And for this one, I'm going to go to the cosine. Once again, you could think of it this way. If you want to just say, hey, that's over 1. Now I'm going to cross multiply. This is the way most students prefer to do this. If I cross multiply, that's y equals 18 times the cosine of 55. And I'm just going to pull up my Casio graphing calculator because I like it the best. 18 cosine of 55. and I get 10.32. Okay, and that was the measurement of BC. And hopefully you understand why this is important as you look at this thing. Before, when we wanted to find the missing side of a right triangle, we needed at least two of the sides, right? We needed two sides so that I could do my Pythagorean theorem. But here I only have one side of the triangle, and I'm able to find all the rest, okay? And it's based on the relationship between the size of the angle and the size of that opposite side. It goes back to that relationship within triangles, which means if I have one side of this thing and I have some angles, well, then all I need is one angle and one side in order to find the remaining measurements, okay? And of course, I could find the missing angle up here simply by saying, hey, these add up to 180, all right? So if I wanted to find the missing angle here, it's going to be a 25 degree. And really, I could have used that 25 degree angle in my trig ratios as well, okay? I could have done the sine of 25 degrees would have been the opposite, which is y, over the hypotenuse, which is 18. And if I solved that ratio, that proportion, I would get the same thing, okay? So it doesn't really matter which angle you use, whether it's A or B here. It just matters that the ratio is set up properly. So taking a look at this one, using the same kind of thing here, notice I have the 62 degrees, and it says find the length of the missing sides. And so if I'm doing the 62 degrees, think about which values I have, all right? As I look at this, I'll call this guy X and this guy Y. So let's say I wanted to find X first. What I have to the 62 degrees is I have the adjacent side, right? I have that adjacent side, that adjacent leg, and I want to find the opposite side if I'm trying to find X. So I have to think about what I have and what I need. I have the adjacent, I want the opposite. Think about which trig function is needed to do that, okay? And so if I have adjacent and I have opposite, the trig function that uses adjacent and opposite is the tangent. So I would say the tangent of that angle measurement, which is 62 degrees, the tangent of 62 should equal opposite over adjacent. That's going to be an x over 8. And we just have to make sure we set up that ratio properly, okay? The side opposite to 62 is the x. The adjacent leg is the 8. And now, once again, I could cross multiply here, okay? So I cross multiply x times 1 as an x. Over here, 8 times the tangent of 62. And again, you don't have to do cross multiplying. You say, hey, to undo dividing by 8, I multiply each side by 8, okay? And now back to my calculator, 8 times the tangent of 62. And I get 15.05. Okay, and that was side BC. And now from here, technically I have the opposite side, but I don't want to use a rounded off answer. So now if I want to find y, think about what we have and what we need, okay? And ignore the fact that we know what BC is now, okay? I don't want to use that rounded off answer. So go back to what I originally knew, which is 8, which is the adjacent side, okay? So I have the adjacent side, and now to find y is the hypotenuse. So I have the adjacent side, I want the hypotenuse. The trig function I need is the cosine, because cosine uses adjacent and hypotenuse, so that's the one that I want to go with. So here, cosine of 62 degrees equals adjacent over hypotenuse. The adjacent side, or the adjacent leg to the 62 is the 8, and the hypotenuse is the y, okay? And now from here, I cross multiply. This is why students prefer to use cross multiplication, because it kind of makes sense to them every time. In this one, you can't multiply each side by 8. You could use your rules of proportions here if you remember those, but most students prefer to do this. They just say, hey, let's cross multiply. That's 8 equals y times the cosine of 62. And now to solve this, I have to divide each side by the cosine of 62. Okay? And this is why, remembering your rules of proportions can really save you some work here. So I get this, I get y equals, I just have to do 8 divided by the cosine of 62. So again, here's my calculator, 8 divided by, and some calculators can be a little bit squirrely here. I'm just going to punch this in with parentheses. Okay, and I get 17.04. And that was side AC. Okay, so I found the missing sides. Going back to what I said in terms of rules of proportions, And this is why this is important. If I put this cosine over 1, remember in a proportion, you can switch the diagonals. So I could switch the y and the cosine of 62 and immediately go to y over 1. Y equals 8 over the cosine of 62. It does save you a little bit of work, okay? If you remember that rule, you can switch the diagonals, okay? If I look at this one, once again, I didn't leave myself a whole lot of space here, but that's okay. So once again, I'm looking at the 19 here, which is angle A, and I have the opposite side to that, all right? And I want to find the adjacent side and the hypotenuse, okay? And so once again, I have the opposite side. Let's say I want to find x first. I have the opposite side. I want the adjacent side. So that involves of opposite and adjacent. That's the tangent, okay? So the tangent of 19 degrees equals opposite over adjacent, 15 over the x, okay? And once again, this is a situation where I could, maybe if I rewrite this, just so you can see it a little bit clearer, you could cross multiply here, okay? Or you can use that rule for proportions where you just say, hey, you know what? I can switch the diagonals, okay? And you'll get the same thing either way, but if you switch the diagonals, you get x over 1, which is just x, equals 15 over the tangent of 19, okay? And see, again, that's just those rules that I've already established. So let's see, 15 divided by the tangent of 19, okay? And I get 43.56. Likewise, if I want to find y, right now in terms of the 19, I have the opposite side. Y is the hypotenuse, so think about which trig function uses opposite and hypotenuse. It's going to be the sine. So the sine of 19 degrees, and again, I could just put it over 1 if that is a little bit easier to read, okay? And then the ratio that it gives me is opposite over hypotenuse, well, that's 15 over y, okay? And once again, you could cross multiply and solve, or if you know your rules for proportions, you can just switch the diagonals. And if I switch the diagonals, I get y over 1, which is y, equals 15 over the sine of 19, okay? It's one of those very underutilized skills and techniques that you can use, especially when you're solving proportions, but really saves you some time here. You can always switch the diagonals, okay? If you're not comfortable with that, if you don't think you can remember that, well, that's okay. Just cross multiply and solve. You'll get the same thing. Okay, sine of 19 degrees. So I get 46.07. All right. And I'll just come and label them on the picture since I'm kind of out of room here. This was the 43.56, and this was the 46.07. Okay. The last thing we're going to do here is we can use these inverse trig functions. That's what these are, and they're on the calculator as well. Typically, they're located as a second function above like the sine. So if you have a sine button right above it in little letters, you probably see sine to the -1. It just means the inverse of sine. And really, that's used to cancel this out. Just like any other operation we have, like we use subtraction to undo addition. We use multiplication to undo division. Okay, we use roots to undo exponents, all right? We're going to use inverse sine to undo sine. We're going to use inverse cosine to undo cosine. We're going to use inverse tangent to undo tangent, okay? So we set these up the same way, but if I want to solve for the angle, I have to cancel out the trig function that I have. I have to cancel out sine or cosine or tangent, and I use these inverse operations to do that, okay? And so if I look at something like this guy, notice I want to find the angles. So let's say I started with angle B. So angle B right here, I don't know what it is. I'm just going to call it x, okay? I don't know what it is, so I'm going to call the measurement of angle B, I'm going to call it x degrees, okay? And so if I'm focusing on angle x, or angle B, which is represented by x degrees, all right, I think about what I have. I have the side that's opposite that, and I have the hypotenuse, so that tells me which trig function to use, opposite and hypotenuse. This is the opposite side, and this is the hypotenuse. So I'm going to use the sine function. And again, it's sine of the angle, which this time happens to be an x, because I don't know what it is, equals opposite over hypotenuse. Well, that's 12 over 18, okay? And the thing about this is, well, how do we solve this? Let me give myself a little more space. But the question is, how do you solve this? Well, I have to get rid of the sine function. I have to get rid of the sine operation that's happening with the x. Well, the way we do that is we use the inverse sign, okay? Just like addition and subtraction cancel each other out, to cancel out sine, I just take the inverse sign of it, essentially, is what I'm doing, okay? And see, what happens is those will cancel each other out, and I'll just be left with x. But just like any other equation that we've ever solved, whatever I do to one side, I have to do to the other side, okay? And so I have to do that to this side as well. So what happens is over here, I just get x. Over here, I have sine to the -1, or really the inverse sign is really what that really means. Okay, the inverse sign, and that's just notation. It's not actually sine to the -1st power, it's just inverse sign, all right? And I should give myself a little more space. But there's a button for that on the calculator. I'm just going to plug this in, okay? So it's the inverse sine of 12/18 is what I'm left with, okay? And let me show you on all three calculators where to find these things. All right, so if I look here on the one on Schoology, once again, you have to hit this second key here. So you see the thing that said second. If you hit second right there, now all of these have switched. Now, all of a sudden, I have the inverse sign, okay? And it comes up like this, but I believe it was 12/18 or 12 divided by 18, and you can close those parentheses. And it solves, it works backwards to get the angle, okay? Same thing with the TI and the Casio. If you look right above the little sign button, you see in yellow there. So I just hit the second key and then hit that, and we can see it. Okay, and again, that's 12 divided by 18. Oh, if I could hit the buttons properly. Okay, and lastly on the Casio here, once again, right above the sign button, just like the TI, we hit Shift, and that gives me that second option above there. And then it's 12 divided by 18. And it's a good idea to close that in parentheses, just so we know. Okay? And for all three of these, it gives me 41.81 degrees. So x equals 41.81 degrees. But that's it. And essentially, all we've done here is we've learned a new operation in sine, cosine, and tangent. And now we've learned the inverse of each of those, which is inverse sine, inverse cosine, and inverse tangent, okay? If I want to find the other angle, I'll call it y up here. Let's say this is y degrees, so angle A. Think about what I have. I have the adjacent side, the side that's adjacent to A is the 12, and I have the hypotenuse, so that's my cosine function. So once again, I'm going to say the cosine of y this time equals adjacent over hypotenuse. Okay? And once again, to undo, sorry, I should have given myself a little more space. To undo the cosine, I just use the inverse cosine, okay? That's what this operation is. Let me section that off a little bit. So I just do inverse cosine of each side. So if I do that to this side, I have to do it to this side, okay? And again, the thing that's confusing to students is we've never seen anything like this before, but we just need to understand these are inverse operations. They cancel each other out, okay? And these are not operations that we're familiar with, not operations that we've dealt with in the past, okay, which makes them a little bit strange, and we don't understand the process behind these functions, all right, which kind of makes it like we're kind of going in blind, okay? We understand the process of addition and how it works. We understand the process of multiplication and how it works, so undoing those things makes sense, okay? But really, you have no basis for the process of the sine. You just have to trust me that the sine of this thing gives you that ratio, okay? And that the inverse sine will cancel out the sine function, okay? And so once again, I just plug this into my calculator, second cosine, so the inverse cosine of 12 divided by 18. And that gives me 48.19. And the other thing that we should point out here is really, did I need to use trig functions to find that second angle? And the answer is no. Hopefully you were laughing the whole time I was doing that. You should realize that this is a triangle. The three angles inside the triangle have to add up to 180. So you only need your trig function to find one of these. And then you could find this by saying, hey, it's got to add up to 180 for inside this triangle, okay? I did them both just to show you a little bit more, to give you a little bit more practice with looking at those inverse operations, okay? So again, make sure you understand that it's the sine, cosine, or tangent of some actual angle equals that specific ratio, and you have to know those ratios. And then to undo that when it's needed, we use those inverse sign buttons on the calculator, okay?